All right, our next set of systems of equation is quadratic and linear. That means we're going to cross a parabola with a line. And for this one, there's another, there's different possibilities that can actually happen. And there's three again. For the first one, it's the most common one where you're going to always have two solutions. Okay, you're going to have two solutions. The second one is you just have one. It's running tangent to it. You remember that from geometry. So this is just one solution. But what we like to say in math, it's two solutions with a multiplicity, or one solution with a multiplicity of 2. Because you will always have two solutions technically. And here there is no real solution. Ooh, I can write. It's just it's really hard to write. Is that even readable? It says no real solutions. And that means these are going to be imaginary or complex, depending on, the equation. All right, so most of the time we're going to get two solutions, but the other ones definitely happen. When we're doing this, it's really the only option we have is substitution. So that's why that's such an important one when you learn linear. Y equals 3x minus 6. I'm going to plug that in right where the y is there. So 3x minus 6 equals x squared minus x minus 6. And we just solve it. Okay, so take a second, set it equal to 0, solve. I'm going to pause and then just show you the answer. All right, when I solve this, I got 0 and 4. Just take a look at it. You may have to pause and look. When this happened, you got x squared minus 4x. Remember, that's just GCF. That's not dots. It's not a trinomial. It's simply GCF. So I wind up getting two answers. X is 0 and x is 4. So I have 2 points where it's crossing. These are my x coordinates for both of those, so then we just have to figure out our y. I generally take the easier one, which is this one. But you can use, again, either of them because they share these 2 points. And I simply plug in x equals 0 here, so y equals 3 times 0 minus 6. So y equals negative 6 for this one. And when I plug in 4, y equals 3 times 4 minus 6. That is 12 minus 6, which is just plain old 6. So when it hits at those 2 points, and those are our solutions. All right, so then we have another example of this. So neither one of these is solved for x or y. So you just have to do that. So if I want to solve, y seems like the easier one to do here. So I'm going to take this one and solve it for y. So 5 equals y minus x. I'll simply add x. So y equals x plus 5. So I'm going to take this and plug it in for y right here. So I'm going to rewrite that whole equation. 4x squared equals negative 17x plus y, but this is my y now. X plus 5 plus 4. Now if there's something to multiply, those parentheses are necessary. In this case, they're really not. So take a second and solve this yourself. Okay, that was fun, yes? Sure it was. Okay, so I just solved, I plugged it in, and when I wound up factoring, I factored this mess. I solved, got it set equal to 0, factored it, got these two. You could always use the quadratic formula, but you do need to get an answer in the end. And then I got 1/2 and negative 9 over 2. I believe it's right. If you multiply these two together, you get positive 18 minus 2, and that's a positive 16. So, me and my mistakes, but I'm fairly certain that's right. Okay, so now we have 2 points. One of the x coordinates being 1/2, the other being 9 over 2, negative 9 over 2. And I simply plug in. Again, we like fractions more. Your calculator does it all. You can write it as decimals, but if they don't tell you to round, don't. That's all I gotta say. So we just plug these in. and this winds up being a half. There we go. Those are our two messed up points, but they are 2 points of intersection. Yeah, that was awesome. All right, so then the last one here. This one's slightly different, and notice the way the question is asked. Determine the exact solution if f of x equals g of x. So the difference here is there's no y. And there's no y in the problem, and there's no y in the answer. So for this one, determine the exact solutions if f of x equals g of x. They just want x's. That you don't need to have to plug them back in and find y. And so when they say exact solutions, chances are we're getting fractions or radicals, so break out your, quadratic formula muscles, and we'll do this. So if f of x equals this and g of x equals that, find out the solution when f of x equals g of x. Well, then f of x is this one. We want to find out where it's equal to g of x. What are the x values to make these two the same? So, if there are any, mind you, there are, they just might be imaginary, you never know. So you simply solve this guy. Okay, so it says exact solution, so I really don't even have to try to factor this. It can't be. There's nothing that multiplies to 1 and adds to 5. This is, yeah. So I'm going to break out the quadratic formula. If you don't remember, try it out and try it yourself. All right, so that's it. Plug in the quadratic formula, and we simply get that x is -5 plus or minus the square root of 21 over 2. 21 can't be reduced, but you would have to if you could. And that's it. Have a good day.